All right, let's run some age models in Mark. So I'm going to start a new project using the example data set in Mark, age 2 class. That's the one I want. And I know it's got 5 encounter occasions, 1 group. Okay. And bingo, I get right into my PIMS. And what I want to do is set up the PIMS for the model phi t/t p p/. Okay, and that's just what they started off with. One thing I'm going to do, I'm going to run a predefined model. I'm going to run the phi t pt, the standard, time variation, Cormack-Jolly-Sieber. Okay. It pops up there just because I want to compare that to the other ones. So now we are going to start playing around with the parameter index matrix, and they're already open. I should have known that. Okay. So we've got 2 matrices that we want to work with. And remember, for the phi t, phi t/t and p/. models, what we want to do is we want to have a different value for every entry along this diagonal. Okay, and that would be the first t in our model. And then we want to have different values associated with each one of these survival periods for the adults. And so you could just type all these in. You already have 1 through 6 here, and then you could type 7, and then you'd have to come and type 8 and 8, and so on, and then 9, 9, 9, so that you have time variation in the juvies and separately time variation in adult survival. I'll show you a cool trick to do this much easier. Type 6 in that top left cell, come up and click on initial and time. Okay, and then bingo, it sets the values to be the same in each column starting with 6. And you say, well, why are you doing that? Well, you'll see in a second here, because I come to initial and diagonal, and I want to modify the number 1 diagonal. That's the bottom one there, and I want to start with 1. And watch what happens. Now we have our juvenile values numbered 1 through 6 for each of the different years, which is how we want it. And then for adults, we also have different values, and those are the same for all the different cohorts. So remember, we're only marking as juveniles. We don't have any adults in that first interval. But once we get to the second interval, those animals that we marked on the first occasion are now adults, so they will have their own separate survival, different from the juveniles. And then when we get to the third interval, now we've got 2 cohorts that could be adults from the first time we went out and banded and the second time. And then we also have the individuals that were banding as juveniles that first time. Okay, so just an easy way to set this up. And now I want to set up the P to be the same as what they use in the book, and that's a P/. So that means that all the same values on the diagonal, that capture probability for juveniles is all the same across all years, and then same value for all adults, saying capture probability is the same. And we know that we have got 11 parameters already with phi. So now we have 12 and 13. So what I'm going to do is type 13 in that top left corner and click constant. So now I've got all my adult values set. So now I can come down. I don't know of any way of quickly doing the diagonal all the same. So I'll just type all these in, and it's easy to make a mistake here. But then we've got it. Okay, that wasn't too bad. So just to review, we have phi t/t, so all the time variation, but just different for juveniles and adults, and p/dot, different capture probabilities for juveniles and adults, but always the same across years. So we're going to run this current model, and I'm going to call this phi t/t p/dot. Okay. I'm going to say OK to run. Yes. Go ahead and use the identity matrix. Append this. Yes. Okay. So we put age into the model, and oh my gosh, look what happens. The delta AIC for that just time variation only model is 983 units lower. So not even nothing to even think about on that one. Okay. And I'm going to do something else here just to save a little bit of time. I'm going to unclick this that says show message when model is retrieved, and I'm going to click this that says turn off warning of using identity matrix if no design matrix window. So we always use the identity matrix if we're just using the PIM. You don't really need to click OK when you retrieve a model, so just saves a few clicks. Okay, so we've got our phi t/t and p/dot. So I'm just going to stick with that same P model, and now I'm going to modify this so that we have the phi dot/dot p/dot. Okay, that should be pretty straightforward. I'm going to go into the PIM matrices. They're already open. I should have known that. I'm going to shrink them a little so we can see them both. So there's the matrix for the capture probabilities. Here we come along for the survival. Okay, so now we want to really simplify this survival matrix. We want the same value across all of the number one diagonal, and then the same value for everything else. So I'm going to do a little trick and click put 2 there and say initial constant. Everything is 2. So all I have to do now is change these all to 1s. And I'll have my model set up. And I'm OK to run. Current model. Yes. And now this is changed to p/dot p/dot. Okay. Okay to run. Boom. Yes. And still way above the time variation only, but a good bit below the t/t model for phi. I'm going to show you a little trick at how you can set up this model more easily using the PIM chart. So I'm going to retrieve that model, go to the PIM chart, and here's a cool little feature. So you come to the phi rectangle, okay, in their chart, right click, and you say, okay, now I want to add age to this parameter. And I only have 2 ages, so I push that down to 2, and I'll do the same thing for P. Okay, so now we're down to just 4 parameters, and I'm going to say renumber with overlap. So phi is 1 and 2, P is 3 and 4. You think, okay, we're great. It's always good to check and make sure the parameter index matrix is set up correctly, because it can look fine on the chart, but it could be wrong in the actual matrix. It shouldn't be, because Mark set it up presumably correctly, but here we go. The 1s are all along the diagonal, 2s are all everywhere else for phi, 3s are all along the diagonal, 4s are everywhere else for P, so good, we've got it. I'm not going to run this because that's just the same model that we ran before, and that's not very interesting. Let me just show you one other thing. So say we wanted to run the phi dot t model. Okay, so remember, for that you'd have 1s all along this diagonal, and then you'd have different numbers in each one of these columns, because you're saying that adult survival can vary by year, but juvenile survival is constant. Okay, so that would be phi dot t. All right. So again, one quick way to do that is to come here, set that to 2 and initial, and say time. Okay. So now it's 3, 4, 5, 6. No, I want that set to 1. Sorry. And come to initial and time. So 1, 2. Yes. And then everything along the diagonal I will change to a 1. Okay, so that's my phi dot, no variation, /t. The adults can vary by year in their survival. So again, that's going to mess up my parameter values for P. I can come to the chart and see they're stacked on top. We don't want that. And we can say renumber, no overlap, and boom, it'll push it over. So now we have parameter 1 is juvenile survival, and then your interval 2 for adults, 3, 4, 5, 6. Okay, so we could run that current model, and this is going to be phi dot /t. Okay. PT. Well, I'm not going to worry about P's right now. We know that's probably not going to be such a great model, because it's got not bad. Okay, so you've got juveniles all having the same survival. Adults survival varies by year. Probability of recapture varies by year. All right, so now let's do something a little more interesting. Let's get into our design matrix approach. So I'm going to click on this top model, and now I'm going to say design and reduced, and I want this to equal, oh, you know why it's doing that? I haven't retrieved this model. So I'm going to retrieve this top model and then say design reduced, and it should be 13. Yes, I'm going to stick with that. That should work for us. Let's see, you can always change the number of columns if we need to. So now we're going to run this phi t/t model. with a design matrix. So first thing we have to do is set the intercept for phi, and so I'll do fill column, partial intercept, and I want to go to 11 because there's 11 phis. Okay. And then I want to do that again because I want a partial intercept for age. And in this case, it's going to be 6 because we can estimate juvenile survival across 6 intervals. And remember, as we talked about in lecture, you can only do it for 5 intervals for adults because we're only marking animals as juveniles in this population, or in this study, so we can't get an estimate of adult survival across that first time interval. Okay, so now we add in the time values, so we can do fill and partial identity, and here we just want to put in 5 because that'll give us variation for time 1, 2, 3, 4, 5, and then 6 will be all zeros in the last row here. Hopefully you remember that from what we did before. And now we have a strange one. For adults, we have one fewer interval that we can estimate survival for. We can't do it for that first interval. So our ones start on the B4 column, okay, but we will do a partial identity, and now we just need 4 ones to go in there, okay, and those stack on top of each other. So here's the year 1 effect only on the juvies, or the interval 1, 2, 3, 4, 5, and then that last column will give us 6, or last row. All right, so the only other thing we have to do are the intercept terms, and again, this one's a little tricky. You don't do it across the top row because you can't have an intercept effect of being adults or juveniles because you have no adults yet. And so I'm going to fill partial identity, just go with 4. Okay. And then for the recapture probability, it's pretty straightforward. We just have 1 for the juveniles and 1 for the adults. Okay. So if we go ahead and run this, I'm going to run it, and it will be our phi tt t/t p dot/dot. Okay, but I'm going to make sure I realize that this is the design matrix, DM. All right, boom. And if I did it right, it will be the same. And yes, it is. Whew. Okay, so just 2 different ways of doing the same model. Why do you go to all that trouble? The reason is once you set it up with the design matrix, now if you wanted to do the additive model, it would just be very easy. All you'd have to do is delete these 4 columns, take out the interactions, and then you'd have the additive model for survival, where survival of adults and juveniles varies in parallel from time step to time step. But let me show you something that is very interesting here, okay? So I'm going to make sure I've retrieved that model. And now let's look at the real parameter values, okay? So these are the estimates for phi and p. And you see for the juveniles, 0.32, 0.44, first 6, and then it jumps up and it's much higher for the adults, as you might expect. Let's look at this for the model that we ran with the PIM, and hopefully we'll get the same values. If we don't, this is like, yikes. Okay. So there's one I just showed you. Here's the one with the design matrix over here, okay? And you can tell because design matrix is on the left, PIM is on the right. For the interesting, yeah. Okay, so the real estimates should be matching each other exactly, and they do, 0.3234, 0.3234, and so on, okay? But what happens when we look at the betas? So here are the betas for the PIM model, okay? And you notice that they say phi 1 through 11, P 12 and 13, okay? So here are our betas. So let's retrieve this model now and get the betas. And do you think they're going to be the same? Probably, since I'm asking that way, you're going to think, no, and you would be right. Okay, so now we've got both of these windows up, and we look at the estimates, and it's like, oh, so with the design matrix, parameter 1 is 1.0567 something. Okay, for the PIM, it's minus 0.360 something. Okay, what's going on here is, remember, we use the identity matrix when we're running from the PIM, and we just tell Mark where all of those different parameters are found in our matrix, okay? And it just runs that against the identity matrix, so we get a different beta for each one of the parameters that we're estimating, okay? But with the design matrix, we're building a model where we're saying that survival of time period 1 is the intercept plus the effect of beta 2 plus the effect of beta 3. Remember, we went through all that. And the reason we go to all that trouble is that now that allows us to look at the effects of these parameters independently, okay? So this first one is the intercept. That's not too interesting, but the second one is very interesting. That is the age effect, okay? And you can see that it's fairly largely negative. It does slightly overlap with 0, so not quite significant at the 95% level, but indicates a strong effect of age on survival, okay? And we'd expect that looking at the results. And then this would be the effect of the interval 1 on survival, 2, 3, 4, 5, and 6, and then we have our interaction terms, and then we'd have 12 and 13 would be the P's. Okay, so important to know the distinction and know which ones of these will be able to tell you interesting things about the effects that we're interested in this case, age. Okay. Oh, another thing while I'm here, you can easily output these by clicking on save as, I believe. No. How do I file? Pretty sure there's a way to get this to export in directly into Excel. Yeah. I'm not seeing it here. Weird. Um, Let me just check on the real parameters. File. Thought it would. Yeah, dang. There's something I'm missing. Um, I know I did that. It's going to kill me. All right. I know what I do. You select the model that you want to get the output for, and then you come to output. So let me make sure I've got that one. Yeah. And then you come to output. And say you can either have table of model results, specific model output, parameter estimates, real versus beta, and then you can put those into Excel. And generally, we're going to want to copy, everything with the standard errors and the 95% confidence intervals, because we like to know what the values of those confidence intervals are. Why didn't that output? Output parameter beta. Oh no, I have to click on output it to Excel, and then that will give you. I can't for some reason bring it in here, but it'll just basically paste those into Excel so you can clean them up and put them into a table in Word. All right, so let me now do the final things, and that is show you how to manipulate these design matrices. So it would be very easy to do the additive model. You could just remove the 4 interaction terms, and I'm going to do that right now, 8 through 11. And now I'm not going to run this model. It is one that I ask you to run, but I'm just going to go to another model that I ask you to run, and that is the model where you allow time variation in juvenile survival and no time variation in adult survival. So the fact that you just have the ones here for the intercept and no other ones indicates that we're just going to estimate one value for survival for adults for all time periods. Okay, so I can run that, and this would be model phi t dot slash dot, okay, and then p dot dot, okay, and run that, and it'll append it. And I don't expect that to match the others because we didn't have, this model was model dot slash t pt. Okay, so hopefully that gives you kind of an understanding of how you set these age models up. Don't, beat yourself up. These age models are hard to get your head around. It's just because these animals, start one age and then move to another. It just gets tricky when you're setting up even the PIMs for these things. So just work through it. You're essentially there now. You know how to do everything with Mark. You have time variation, you have age, you have time covariates, individual covariates. So really, we've given you the guts of everything you need to know. And from now on, it's just running different models like the known fate model and the closed capture models and so on. And they're all just going to be variations on this, going to be differences in how you set up the data and bring them in, but you're really pretty far along right now.